When we discharge this massive capacitor bank, it delivers over 2,000 watts of power. All the sparks you see here are generated by this tiny little microcontroller. So how does it work? A capacitor is basically like a rechargeable battery, but instead of storing chemical energy, it stores electrical energy in an electric field. When you charge a capacitor, you build up a voltage difference between its plates, which creates an electric field. And once that voltage difference is established, the electric field will do work when we connect a load to the capacitor. The capacitor will discharge through the load, and the amount of current it can deliver depends on the voltage difference between its plates and the resistance of the load. Now, to make a long story short, this circuit uses a P-channel as a switch that connects and disconnects these capacitors to ground, rapidly switching them from an almost fully charged state to a fully discharged state and back again. And this action is what generates all the spark. But there's a lot more to it than that. The first thing we need is a way to charge the capacitors. This circuit uses two capacitors and a resistor to create a step-tone waveform that charges the capacitors at different rates. This waveform is then smoothed out by an RC filter made up of this 100K resistor and this 100 NF capacitor, which creates a charging signal for the capacitors. Next, we need a way to control the capacitors switching. This is done with a P-channel MOSFET, which acts as a switch that connects and disconnects the capacitors from ground. When the gate of the MOSFET is connected to ground, the capacitors are connected to ground and can discharge through the load. When the gate of the MOSFET is not connected to ground, the capacitors are disconnected from ground and can charge up through the charging signal. Now, when we connect the load, current will flow through it until the voltage across the load drops to zero. At this point, the capacitors are fully discharged and the load will stop drawing current. If we keep the gate of the MOSFET connected to ground, the capacitors will continue to discharge through the load, and eventually the load will start to charge the capacitors back up. This will cause the current to flow in the opposite direction through the load, which will generate a spark if there's a gap to ionize the air. So there you have it. That's how this simple circuit generates all these sparks. I hope you learned something new today. If you did, hit that like button and stay tuned for more videos. Goodbye.